Okay, here we're going to be doing some more work with hypothesis testing and determining the correct alternative and null hypothesis for particular problems. Again, this is an area where many students struggle, so we want to take a little bit more time here and work through some practice problems to make sure we've got this understood well. So here we're going to be using practice problem number 7 from page 390 in your text. And here we're looking at the claim that the mean pulse rate of adult females is 76 or lower. And we're going to be looking at data from a random sample set of adult females as presented in your text in data set 1. And that data set shows that the mean pulse rate for women is 77.5. So we're going to go through these 3 steps here on the right, where we're going to be identifying a specific claim or hypothesis that's to be tested and put it in symbolic form. We're going to give the symbolic form that must be true when that original claim is false. And we're going to present these in terms of hypotheses formulas. So the first thing we need to be asking here again is what is the property that the problem is asking about, and also what is the expected value. So looking at this particular question, what is the property that they're at population parameter that they're asking about for this problem, and what are they expecting the value to be? Take a moment to identify that and get it in your notes. Well, what we're looking at here, as they say, is they're looking for a mean. So that's going to mean we're looking for a mu. And the expected value here, as they show, is 76 or lower. So that is what we're setting up for the particular claim here. Now remember, we need to put our null in terms of equals to. So if we put our claim of 76 being 76 equal to or less than, we're going to translate that into our mu being equal to 76. So that is going to be what we have here. And then the symbolic form that would be true if that is not true, looking in terms of, since they've set it as being equal to 76 or lower, then we're looking at it in terms of being greater. So we're going to have our mu as being equal to 76, being greater than 76 here. Sorry. So here are our 2 symbolic forms, and then when we put them into a hypothesis formula, we're going to get a null of mu equals 76. That's the current state of affairs. And then our alternative is mu is greater than 76. Now let's take a moment to talk about what were the sources for the null and the alternative hypotheses here. So the null is always going to be the status quo, what we currently know. So here we're looking at the fact that we currently believe that adult females have a pulse rate of 76 or lower. All right. Now, so that's the null, that's the current state of affairs as we know it. The alternative is going to be the challenge to this claim based on a data set. So here the person is saying, well, I think that the pulse rate for females is actually going to be higher than 76. That's too low. And I'm going to then go collect some data on women's pulse rates. And based on that data, I'm going to find out whether or not I can refute the claim that the pulse rate for women is 76, whether or not that's a true statement. So when you're looking at your null and your alternative, the null is always going to be the current state of affairs as we know it. The alternative is going to be the challenge that somebody is making to that state of affairs, right? So here we think of ourselves as the researcher. We'd be saying, I'm challenging that and saying 76 is too low. And then I'm going to collect data to assess the accuracy of my challenge to that status quo claim. So my challenge is going to be the alternative, and the status quo as we currently know it is going to be the null. So hopefully that helps you kind of think about your null and your alternative hypothesis in terms of the sources of each of them. So the null is coming from the current status quo knowledge, the alternative is coming from the new data set that we have that we're working with. Okay, let's do one more practice problem here. So this is number 30 on page 392. So here we're going to go through, we're looking at a hypothesis test. Again, we're looking at using the XORT method, and we need to go through and identify our 3 steps here. So again, identifying the specific claim or hypothesis to be tested and put it in symbolic form. So again, what property are they asking about in this particular problem, and what do they expect the value to be? Well, again, we're looking at the proportion, so that's going to be our P, and the expected value, if there's no effect or change, is going to be 0.50. So our null here, when we're looking at this, so that's going to be our P equals 0.50. And now we need to give the symbolic form that must be true when the original claim is false. We need to pay attention to the language that's used here. So if we're looking at this, if the problem is asking for a difference from, that's going to be not equal to. If they're asking for something being greater or more, then your symbol is going to be greater than. And if they're asking for something less or fewer, then your symbol is going to be less than. So make sure you get this set here, paying attention specifically to language and how it helps you understand the direction you're going to have for the claim, your second claim here. If the original claim is false, what we'd be proposing. So looking at the problem we have here, we can see the language is where they're proposing it's different from. So when we plug that in to that simple equation that I gave you before in the previous lecture, we're going to get p is not equal to 0.5. So here we're going to then put this in terms of our hypotheses, and we get that our null then is going to be p is equal to 0.5, again if nothing has changed, and that our alternative hypothesis is going to be p is not equal to 0.5. So it's not saying whether this can be greater than or less than, they're just saying it's not going to be equal to 0.5.